Now, problem number 53 uses the exact same factoring patterns that we just talked about when we did problem number 44. And if you missed that, it's these three ideas right here that we are able to factor. Let's get our vocabulary right. We are able to factor a difference of squares. We are able to factor a difference of cubes, and we are able to factor a sum of cubes. The one thing here we are not able to factor, if you ever saw this, which would be a sum of squares, this one does not factor into anything nice as a general rule. But if we look at this mess over here, again, I should try to get my things in order here. With the a value that bothers people sometimes, but let's see what happens if we did plug and chug. If we let x actually equal 0, what's going to happen up on the numerator there? A 0 plus a cubed is going to get us a cubed minus another a cubed, and down on the bottom, that x becomes 0. Well, not surprisingly, we end up with 0 over 0, which means we can't evaluate this limit by direct substitution. Whoop, whoop, whoop. Okay, let's try that again. All right, so getting rid of all that, we need to be a little bit creative on this one. And even though there's an a involved here, factoring and canceling could work, although actually, I don't think factoring this as a difference of cubes is going to help us get that x there. It actually would, now that I think about it, because at some point there's going to be an x plus a minus a, and that's going to cancel. But I think most of you guys would prefer to go the other route with this, to expand rather than to factor. So what I'm going to do is multiply out the x plus a cubed. This again is an identity that you guys learned at some point over the last couple years, but you may well have forgotten it. But by the time you guys are super cool high school math teachers like Mr. Fontana, I'm sure you'll have it memorized. Again, your calculator would do this for you as well under the expand menu, which I believe is under algebra again. X plus a cubed is going to give you x cubed plus a 3x squared a plus a 3xa squared, and then plus another a cubed at the end of all that. If you guys remember Pascal's triangle, which I know you learned and probably thought was kind of cool at some point over the last year, this is what's happening right here. That's where those coefficients of 1, 3, 3, and 1 came from. All right, let me get rid of all that junk though. So all we have in the numerator now is the expansion of x plus a cubed, but there's still this minus a cubed at the end of it here. And I think you see already what's about to happen with an x on the bottom. Now, I can't stress this enough because this is really important to realize. I think that everybody sees right away that the last two terms in the numerator are going to cancel. The plus a cubed from the end of the expansion of the cube of the binomial, and the minus a cubed that just came at the end of the numerator. So yeah, that's neat. But what's really important about that is that those were the only two terms in the numerator that did not contain a factor of x, and they're gone. That means that every term that is still here in the numerator contains an x, and that means that we can factor and hopefully cancel. So I'm going to show a step right here that some of you guys would probably not show on your own, and that's okay, but I just want to illustrate better what's happening. Three terms in the numerator, they all have a GCF of x. So when I pull that out, that's going to leave me with an x squared plus a 3xa and then plus a 3a squared. That's what's left in the numerator over the x in the denominator. And as is very often the case here in 2.5, the problematic factor of the denominator cancels out with an identical factor in the numerator. So now, with that denominator gone, plug and chug should work. As x is approaching 0, this limit is going to be 0 squared plus 3 times 0 times a, all right, plus a 3a squared. Well, that's 0, and 3a squared is all we're going to end up with here for our answer. Now, if you're a little confused about the format of that answer, let's maybe talk about that. A lot of people will look at a problem like this and say, wait a minute, I thought the answer to these limit problems was supposed to be just a constant, like 7 or 1/3 or something of that nature. And so you're a little surprised when you see the letter A in your answer. But I got to remind you here that in this problem, if we look right here, guys, x is the only variable here, and the a, therefore, is an arbitrary constant. A could be any number that we wanted it to be. So, for example, if we were to do a problem like this where a was equal to 7, well, then your answer would just be 3 times 7 squared. Of course, I had to make this hard, and 49 times 3 would be 147. Okay, if a was -2, your answer would be 3 times 4. The answer would be 12. So this answer, even though it doesn't look like it, is written in terms of a constant. We just need to remember that a is not the variable in this limit. The variable is x, and a can be any constant that we want it to be.